Christian Silva.
And I'm Cato Fabrega.
And this is the Parking Lot Project.
Yeah, so Miss Twain, you told us to be creative, so...
Thank you, Mother. Very nice of you to do that for us.
told us to be creative, so we decided to use peanut M&Ms, because we think those are very creative. And so we have problem number 10, which you assigned us. The variables were that it was a 180-foot curve, and we have a little brief summary, if you can grab that, Christian.
I'll be happy to. Alrighty, so here's our little background information that we want to open up with. First, we are college students at Oregon State University painting large pieces of parking lots to help pay for education. Once Kata and I arrived at the job site, the boss, also known as M&M, informed us that we must paint the parking lines along a 180-foot curb. They decided that the spaces should be 11 feet wide and 17 feet long at a 60-degree angle. Now, they must find the parking angle of 0 equals 60 degrees. There's a little, zero sign.
The theta.
The theta. There we go. Thank you, Kata.
Yeah.
With the given information, they must figure out the space between each line, the length of each parking lot line, the vertical length of the parking lot, and the amount of parking spaces that can fit along the curb.
Alright, thank you, Christian. So, I'd like to start off. Come over here. You can show us the amazing diagram that we constructed.
Of course.
So, we figured out that theta was given, which was 60 degrees, and theta is located right here. Located, over here. And this is going to be a 90-degree angle right here.
Perfect.
So we concluded that a triangle, in fact, has 180 degrees. Therefore, 90 plus 60 equals 150, and 80 minus 150 is 30 degrees.
Great math, Kata.
And the 30 degrees is there. And also, we have the adjacent angle trick, which means that angle is going to be the same as that angle. And this is also a right triangle.
Mm-hmm.
Therefore, same rules apply. A is going to equal 30 degrees, and that is our first variable. So A equals 30 degrees.
Perfect.
So now that we have that, we must find Y. So here's Y. So let me grab this really quick.
No problem.
All right.
Right there. You can't really see it too well.
Yeah, you can't really see it. That is a Y. In fact, a Y. All right. So Y, what we did was we used SOHCAHTOA.
Mm-hmm.
And we knew all the angles over here, and we knew Y, or we didn't know Y, but here's Y right here. And using SOHCAHTOA, we concluded that Y would equals 12.7 feet, because we had 60 degrees here, 90, 30, and we used sine. Yeah, and we found 12.7 feet. So 12.7 feet is the spacing between these two parking lot lines. Therefore, our curve is 180 feet, and 180 divided by approximately 12.7 is about 14.1. Therefore, we could put 14 parking lot spaces on this 180-foot curve, and that was our that was also a variable. All right, on to the next one. So we go to Z. So Z is in fact the full length of this parking lot line. Given 17 feet, that was in the beginning of the problem that was given to us. All we need to do is find this missing part right here. To find that, we already had this line and this line. So this line was given. That's what was happening. This was 11 feet, and we used SOHCAHTOA to find 12.7 here. So what we did was we did Pythagorean theorem, and we did 12.7 squared, which was approximately 161, and then 11 squared, which was 121. And what we did was we subtracted 161 to 121, and we got about 40. And with 40, we did the square root of 40, and that came out to be about 6.3. So the line side length right here, 6.3. So after that, we could do 17 feet plus 6.3 feet, which equals 23.3 feet. Therefore, the full length of Z is going to be 23.3 feet.
Perfect.
Awesome. So yeah. And now, time to find X, which is our last variable. So, we knew that A equals 30 degrees. This is a right triangle, so that's 90 degrees. And that is, in fact, 60 degrees.
Good work.
So, what we did was we used SOHCAHTOA and we used sine. So, the sine of 60, right here, opposite hypotenuse. Don't be tricked though. This is not 17 feet. This is in fact going to be 23.3 feet, which we found using Z. That is why we were doing X last. So the sine of 60, which is approximately like 1.8 something, multiplied by 23.3, came out to be about 20.12 feet. And that's the vertical length of the parking lot space. Just to recap of all this, so we figured out all the variables. Just to recap for you, Miss Twain. Degree A equals 30 degrees. Vertical length X equals 20.12 feet. Y, which was the space in between each line, was 12.7 feet. Z, the length the length of the whole parking lot line is 23.3 feet. And the number of parking spaces along the curb that we can fit is about to be 14 feet. Thank you for watching. Math makes me hungry, so these M&Ms are perfect.
Thank you so much.
Signing out. This has been Parking Lot Project number 10.
2015.